All right, so in the first part of section 2.1, we learned how to change degrees to radians, radians to degrees. Right? In the second part, we're going to be using those ideas in two different formulas. And the two formulas are going to have to do with what we call arc length and area of a sector. Okay, those are the two formulas we're going to look at. So one of the formulas is going to be about finding how long something is. The other one is going to be about finding area. So we're going to start off with that picture. What I've basically drawn in that picture is two angles inside a circle. Each angle has two rays, and the rays hit the edge of the circle and make an arc. And I highlighted the arc in red. I'm going to name each arc. I'm going to call the arc on the right arc S. I'm going to call the arc down here S1. Just two different arcs. I'm going to call the angle that goes with S theta. That's a Greek letter. If you haven't seen that before, T-H-E-T-A, it's Greek letter theta. And that's just a variable that we use in trig when we don't know an angle. It's kind of like using x in algebra. Just a letter you use a lot. And I'm going to call this other angle right here, the small one, theta 1. And R just stands for radius. That's all. Any question on that diagram? All right. So one thing I have to mention about the diagram here is that arc size and angle size are what we call directly proportional. So let me show you what that means. Say you have this circle. It's not in the center at all. So more like that. And I have an angle. And there's an arc. How big is that angle? 90. And how much of the arc, how much of the circle does that arc take up?
Quarter.
A quarter. 1/4 of the circle. Now, if I double the size of that angle, how big would it be? It would be 180. And then the arc would be like that. What happened to the size of the arc? It doubled. So that's what directly proportional means. If you change the angle, arc changes exactly the same amount. Double the size of that angle, you would double the size of the arc. If you made that angle half as big, you would make the arc half as big. So as one thing changes, the other thing changes exactly the same. That's directly proportional. And if you look at the word proportional, first part of it is proportion. So if two things are directly proportional, you are allowed to set up a proportion between them. So let's set up a proportion. A proportion has 4 spots in it. And proportions only apply to things that are directly proportional, which we just said this is. The 4 spots are the numerator and denominator on the left, numerator and denominator on the right. These are what are going to go in the 4 spots. An arc and an angle, another arc and another angle. You can set the proportion up a lot of different ways, as long as whatever pattern you use on the left, you use the same pattern on the right. Okay? So let me start with the left and see if you guys can get the right. I'm going to do arc over angle. Arc over angle. So what do you think would go on the top on the right? Arc over angle again. Okay, so that's the proportion that we're going to use, but you've got to fill some stuff in there. That proportion right now is useless because it doesn't have any numbers in it. Okay, we got to get some numbers in there. It's kind of like if I gave you this proportion, and I said use that proportion to convert between feet and inches. Well, you got to fill in some stuff if you want to be able to do that. Like 12 inches, 1 foot. So I just filled A and B in. Now, you could give me a number for C or D, and I could solve it by cross multiplying. You said C is 200 inches, and you want to know how many feet that is. I just throw 200 in for C, and then cross multiply. But you've got to have a fact you can fill in. So that's what we have to do in this proportion. We've got to fill part of it in, half of it. Okay? And we can leave the other half the way it is. So, what we have to do is suppose that theta 1 equals, and we've got to pick something that's going to make this easy to figure out. Just like here, I picked 12. By picking 12, it made that number very easy to figure out. If I picked 19.6 inches here, it's going to be very hard to figure out how many feet that is. Most people don't know that off the top of their head. Maybe if I picked 24, that would have been another easy one, or 36. But you got to pick a number that makes it easy to figure out. And it doesn't matter what number you pick. 12, 24, 36, I could pick any of them. Just as long as whatever I write on this side is a true fact. And that is a true fact. So, you can let theta 1 be whatever you want, as long as you can figure out what S1 would be, because you did that. So, does anybody remember what we said yesterday about this angle? It's when we were talking about the definition of a radian. Very first thing we said, that if there's something about this angle, it'll be a certain size if two other things in this picture are the same. Anybody remember what it was? If the ray was the same length as the what? It's the arc, yes. If you make that ray and that arc the same length, I know that picture's not to scale, but if they were the same length, how big would it make that angle automatically? Yeah?
1 radian.
1 radian. And that's the fact that we're going to use. Right? That's going to help us. We learned yesterday is if this arc and this angle are the same, then that angle is automatically 1 radian. So let's do that. Let's suppose that theta 1 is 1 radian. That's just like supposing you have 12 inches. Now, tell me what that means. In that case, 12 inches means 1 foot. In this case, if that angle is 1 radian, it means that arc is exactly the same size as the radius. That's how it works. That's the definition of 1 radian. That arc length and radius are equal to each other. Now, fill that information in right there. So, instead of S1, you're going to have a radius, which would be given to you in the problem. In a real problem, it'll be something like this. They'll tell you the radius of the circle, 4 inches. Okay, so you'll know that. And theta 1, we're going to plug in 1. This fact right here is like 12 inches in 1 foot. That's the fact that we're going to start with to figure out everything else. Now, it might look a little more confusing because you're not as used to working with arc lengths and stuff, but this is just the same idea as 12 inches in 1 foot. It's exactly the same concept. Why is it true? Why are there 12 inches in 1 foot? Somebody decided that that's what it's going to be. Same thing here, which is what it is. On the other side, you can leave blank. Okay, I think I already mentioned it, but what do you do when you want to solve a proportion? You cross multiply. This times this equals that times that. So what's S times 1? S equals, and this you can't really do much with. It's just R times theta. And what's in that box is called the arc length formula. So the arc length formula has three variables in it. It has the S, which is the arc length. It has R, which, what did we say R stands for? Radians. And theta, which is an angle. We got to be a little bit careful about the angle. What did we assume way back, or what did we suppose that theta 1 equaled? Radians. Theta 1, when we went through this whole thing, we assumed that the angle was a radian, which means this formula only works in radians. You could make a different version to work in degrees if you wanted. But it won't look as nice as that. It would have a pi and it would have a 180. So that formula only works if your angle is in radians. Three different kinds of questions I can ask you. I will always give you 2 out of 3 of the variables, and you have to find the third one. So I'll either give you the S and the R and the theta, or the S and the theta. And you solve for the one you're missing. Okay. Questions on that formula? Okay. So when you get a question, one way they can give you the question is they can write it all out like that, or the way we're going to do next, they just draw a picture. So the first time, I just wrote out the whole problem. Okay. So example 1 says find the length of the arc. So just by what they're telling me to do, I know the formula to use. You guys only know one formula that I've taught you so far. But the question is about an arc. It's not about area, which is the next thing we're going to do. Right? Since it's about an arc, I should write down the formula I'm going to need right away. That's the formula that deals with an arc. All right, so it says, you got a circle, blah, 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 that's all great. But you have an angle of pi over 3 radians. So that's important. And you have a radius of 4 inches. Find the length of the arc. Okay, so what letter am I solving for? S. Solving for S. We know that, we're going to fill them in. So S equals, what's my radius? 4. And theta, it's supposed to be an angle in what units again? Radians. Did they give me an angle in radians in this problem? Then I'm fine. I don't have to convert it. If they gave me an angle in degrees, that's what we learned yesterday. Step 1 is to change it to radians. So we got 4 times pi over 3. Multiply them together. So what we're going to multiply them, we'll get the decimal after. But for now, I'm going to leave it exact, and then I'll do that after. Okay? So if they want the exact answer to this problem, 4 times pi, 1 times 3. That's the exact answer. Now, what did we just find?
The length of the arc?
The length of the arc. Since you found a length, you have to go back in your problem and look at what units were lengthened. In this case, inches. So that's 4 pi over 3 inches long. Okay. If they wanted it as a decimal, we'll do what Owen just did. Just type it in. Use the pi button. And you're good. Properly rounded, 4.19 inches. Any questions on how I got the exact or the approximate answer? Okay, so let's try same thing, except this time I just drew it as a diagram. Okay, what's the formula that we're using here? S equals R, what'd you say the last thing was? Theta, yes. S equals R theta. Once I teach you the second formula, then you're going to have to decide between the two. If it's an area problem, you're going to use the new one I'm going to teach you in a little bit. If it's an arc length, you've got the formula right there. Okay, so how about, Cameron, what letter am I going to be solving for in that formula?
Solving for S.
Yep, we're solving for S because that's the length of the arc. So that means we know the other two. Chad, what is my radius in this case?
8 feet.
Yep, 8 feet. I'm going to leave feet off for now. That is going to be important when we get to the end of the problem, though. Okay, so 8 feet. And what about theta? What about it? 130? So put in 130 right here? No, why not? Because it's in degrees, not radians. If you plug in 130, it's going to come out wrong. So off to the side, what I'm going to do first is change that to radians. Okay. So what do I multiply by to change that to radians? And divide by 180? Don't even need a calculator for this part. Just cross those out. And it's 13 pi over 18. Good enough. Don't round it off, because then if you round it, you're not going to get an exact answer. So 13 pi over 18. Okay, now multiply these together. But before I do that, is there anything I can reduce?
8.
Yep, 8 and 18. What goes into both of them? 2. 2 goes in 4 times. 2 goes in 9 times. Now I've got something probably not going to need a calculator to do. What's 4 times 13? So 52 pi divided by 1 times 9. So that's 52 pi over 9, and that was a length. What unit is length in this problem? Feet. Perfectly fine to leave your answer just like that. The only time you're going to get a decimal is if they say round to 2 decimal places. Any questions on how you type that in to get a decimal? Yep.
I don't really know how to use those calculators.
How to type it in? So it's pretty much the same on the scientific ones that I'm going to have up there for you guys to use. You just type in 52, the pi button, and I think even on my calculator, you still have to press second and then the pi button, and then just hit divide by 9. And that's it. So the calculators I have you guys use are the ones just like that. It's the TI-30 ones. You type it in exactly the same way. 52, except this one you don't have to press second. You can just press the pi button. There's a button for it. My calculator doesn't have a pi button. I have to press second.
So is the final answer the 52 pi divided by 9, or is it the 18.15?
That's the exact answer, which is what I wanted in this problem. That would be an approximate answer if they said to round it. They didn't really specify in the directions here at all.
Okay.
On the test, though, it will. Okay, so both of those were finding arcs. Second one a little bit harder because you had to change degrees to radians first. Let's look at this one. So just read through it. And then what letter are they asking me to find this time? They're asking me to find theta, which means they must have given me the S and the R.
What does that symbol mean?
This symbol?
Yeah.
It's a Greek letter.
Okay.
It's just like this letter. It's just an English letter. So that's a Greek letter, English letter. So
it just means for the angle.
Yeah. Yep. So let's start with S. What's the arc length here? Pi over 4. And the radius says 12 times theta. Okay, so we got one step. How would we get theta by itself?
Divide by 12.
Divide by 12. So dividing by 12 is the same as just putting a times 12 in the bottom of the other side. That's what happens when you divide by 12. So this is gone. And we get an angle of pi over 48. Now, what's the unit on that? Well, what is theta represent again? It's an angle. Do you measure angles in inches or feet? No. What are angles measured in? Or radians. And what does this formula give you? Radians. So do I need RAD? No. So that's an angle in radians. Now, let's say you had multiple choice, okay, on a test. Okay, and I gave you choices of 3.75, pi over 48, or pi over 4. What are the units on all those choices that I just wrote? They're all radians, yes. So which one is correct? Pi over 48. That's the correct answer. Now, what are the units on those choices now? They're in degrees. And the correct choice now is A. I know it's A because I did it real quick. I just took and converted pi over 48 to degrees, and it's 3.75. Right? So, point here is when you get a multiple choice question on the test, look at the answers. If they're in degrees, you have a little bit of extra work to do after you get this answer. If the multiple choice answers are in radians, this formula is going to give you exactly what you need, because that's the formula is built to give you radians. So some people get stuck, but they look at something like that on the test and they say, well, I see pi over 48, but it has a degree symbol. Is that degree symbol just the same as this pi over 48 without it? No. They're totally different. So just look at the multiple choice answers and make sure your answer matches the correct one. Yep.
Did 12 end up in all three of those?
So when I divided each side by 12, you could basically think of it as, if you didn't want to think of it as dividing by 12, let's move all this out of the way. Just easier to rewrite it. You could think of it as multiplying each side by 1/12 times 1/12 times 1/12, and then 12 times a 12th is 1, because it's 12 over 12. And then here, that's why the 12 ends up in the bottom. 12 times 4 gives you the 48. Okay, so in that one we solved for angle. Let's do one where we find the radius. Okay. So first thing is we will start with our formula. Takari, what's the formula that we keep using?
S equals radius circle 1.
Theta, yes. So fill in everything we can and we'll find what we're missing. Do we know S? Yeah, what is it? It's 13. Do we know R? No, that's the question. Find the radius. Do we know theta?
Yeah.
What is it?
It's going to be
Yes, good job. The angle is 36 degrees. That is not what you fill in. You have to change 36 degrees to radians. So multiply by pi, divide by 180, and 36 does go into 180 exactly 5 times. 36 times 5 is 180. So times pi over 5. Okay, so now we want to get r by itself. We can move the pi and the 5 at the same time to the other side. Does anyone remember what you multiply both sides by when you have a fraction next to your variable? Yep, it's the reciprocal. What's the reciprocal of pi over 5? So 5 over pi. That cancels the 5's and the pi at the same time. Now do it on the other side. 5 over pi. Okay, all we have to do is simplify the numerator, and then that's our answer. What's 5 times 13? So we get 65 divided by pi. And what's r again stand for? That's the radius, and the radius is how long something is. So what should I have on that? 8. In the formula S equals r theta, 2 of the things are lengths. One of them is an angle. So if you're solving for a length, you got to put the length label. Okay. So any questions on how to find the length of an arc, or the arc length formula? You can use it 3 different ways. Okay. So last formula is area of a sector. So diagram I'm starting out with is just like the last one. First of all, if you're not sure what a sector is, a sector you can think of as if you had like a pizza, a round pizza, and you cut it into 8 slices. Each piece of pizza is a sector. A sector has 2 straight sides, and then the top side is curved. Specifically, the curved edge of a circle. And what I've done is I've put 2 angles in the circle. I've called the angle on the right theta, the one on the left theta 1, just like I did before. Except now I'm not focusing on the length of the arc, I'm focusing on this. That's the area inside that shape. And my goal when I'm done is to be able to come up with a formula for the area of that shape. Now, it's not a triangle, it's almost a triangle, but a triangle would have straight sides, right? We have this like leftover piece right here that's kind of curved. So we can't quite use the formula for area of a triangle because that shape's not really a triangle. All right, so first thing we're going to look at is whether or not this is directly proportional. If it is, we're going to be able to set up a proportion. So let's look at this. All right, and what kind of angle is that? It's a right angle, it's a 90. And the area taken up by a 90-degree angle is that much of the circle. How much is that? It's a quarter. You've covered 1/4 of the circle. All right. So now, if you double a 90-degree angle, what do you get? You get 180. And now the area is that much. So the angle doubled. How much? What happened to the area? It doubled. So angle size and area are directly proportional. If you double the size of the angle, you'll double the size of the area you cover. If you made the angle half as big, the area that you covered for the sector would be half as big. So any questions on that idea? All right, so since they're directly proportional, we can set up a proportion. So 4 things have to go in that proportion. Area, an angle, an area, and an angle. You can set it up any way you want, as long as however you do it on the left, you do it on the right the same way. So, a lot of flexibility before we start. Anyone think they could tell me what you could put on the left?
A1.
Over?
Theta.
Sure. Could do A1 over theta 1. Now that we've made that choice, what goes on the right is only one thing. You have to get this one. You can't. You have no more options now. A over theta. But why? I mean, we've got a proportion. That proportion is correct. But why isn't it very helpful right now? There's no numbers in it. You've got to get the 1 foot, 12 inch in there. You've got to get a fact in there that's true. Any fact. The simpler, the better. But as long as you can put a true fact on one side of this, you'll be good. Okay? So that's what we're going to try to figure out. All right. I'm going to go back here. So we started with a 90, we did a 180. Let's go like this. How big of an angle did I just draw that time? 270. So this was 90, 180, 270. And how much of the circle does it take up? Okay, so this took up a quarter of the circle. This was half the circle. When you do a 270, it takes up 3/4 of the circle. Let's go like this. Here's my initial side. Here's my terminal side. How big of an angle did I draw this time? 360. And how much of the circle does that take up? One whole. Takes up the whole circle. So that's a connection between angle size and area size. If your angle is 360, it takes up the whole circle. Now, we want to think of this one in radians again. So, anyone remember from yesterday what 360 is the same as? 2 pi. All right. So, if your angle is 2 pi, the area is the whole circle. So what we're going to do is suppose this time theta 1 is 2 pi. That automatically makes A1 the area of the whole circle. We just need to remember the formula for the area of a circle. Anybody remember what the formula for area of a circle is? It's pi r squared. Now, if we didn't know that fact, then we're stuck. Then we have no 1 foot 12 inches. We have nothing to start with. But from geometry, we've got that to start with. Okay? So here's the connection. If you make your angle 2 pi, I guarantee you the area will be pi r squared. Why? That's from geometry. You could have given me another fact too. You could have said, well, if we made the angle pi, then the area would be half a circle. But most people don't remember the formula for the area of a half circle. They remember the formula of the area for a whole circle. Okay? So, fill in these two facts on the left-hand side, and that's our 1 foot 12 inch fact that we can start with, and then we'll simplify from there. So, A1 is pi r squared, theta 1, 2 pi. The other side, you always leave it empty, because that's the stuff you have to fill in when they give you a problem. A over theta. Now, how do we solve a proportion? Cross multiply. But is there anything I could do first? Yeah, what happens in that first fraction? Pi's are gone. So now when you cross multiply, all you have is, put it down here, 2 times A equals, and then cross multiply this way. R squared times theta. Now that's not a formula for area. That's a formula for double area. We don't want double area. I want A. So how would I get the 2 on the other side? Divide each side by 2, which is also the same as multiplying each side by what? 1/2. Same thing. Take half of that. Take half of that. Half of 2, gone. It's 1. So the area equals, and this is the order they normally write it in the textbook, 1/2 r squared theta.
You do r squared theta divided by 2?
You could, yeah, you could do r squared theta divided by 2. You won't see it in our book that way. You're going to see it that way, but that's the same thing. All right. Now just write down what each thing means. So this is your area of a sector. So it's the other important formula for today. Okay, A is area. What do you think R is? Radius. And theta? Angle, what about it? In radians, yes. Just like the last time, this is a formula that only works if you put your angle in radians. Very similar to the last formula. There's 3 variables. They're always going to give you 2 out of 3. Plug in the 2 you know, find the one you don't know. I think the longest one is when you don't know R. That's the one that involves the most steps. When you don't know A, not bad. When you don't know theta, it's not that bad. When you don't know R, it takes a little longer. We'll try one of each. Okay, the first one. First thing, when I read the directions, I have to figure out now, am I using arc length formula or am I using the area formula? Bless you.
Thank you.
Which formula am I using here? Right, because it says area right there. S equals R theta is not going to help you. They don't want to know the arc length, they want the area. So that's this region in there. It's the area. Okay, so what's the formula for area of a sector?
A equals R squared, theta over 2.
Yep, and again, just to be consistent the way the book does it, I'm just going to write it as 1/2 R squared theta. But if you want to do over 2, it's the same. Okay. So I don't know A because that's what the directions are asking me to find. What's R? 4. And what's theta? Pi over 6. Okay, so if I was doing it, I'd probably do a lot of that in one step. So the way I would do it, you follow PEMDAS, do your exponent first. What's 4 squared? And then half of that.
8.
So you have 8 pi over 6. And now, what number goes into both 8 and 6?
2.
2. So 4 pi over 3. And that's your final answer. Okay, now we're going to think about a label. What did I just find? Found area. So let's go back up. What should I put for a label on it? Centimeters squared, right? So area is always 2D, 2-dimensional. So centimeters squared. If they wanted a decimal for that, you type it in on the calculator, just like I showed you a little while ago. Okay. So any questions on how to find area if they give you R and theta? So let's look at how to find R if they give you the other things. Now, the directions in this problem say find the radius. How do you know if you should be using the arc length formula or the area formula?
Depends on what they gave you for the inches squared would be the area.
Right, they gave you inches squared. That tells you right there they're giving you an area. So you've got to use the area formula. So A equals half R squared theta. So, as Owen just said, we got the area. That's 8 pi over 3. Okay, the 1/2, we're just going to leave it. What are we filling in for R? R, we don't know it. So as I told you, this is probably the longest one. You don't know R. And what are we filling in for theta? You have to change that. So right here, we can just change it. Pi over 180. And 45 goes into 180 a nice amount of times. How many times does it go in? 4. So this is pi divided by 4. Any question on that? Well, okay if I erase it because I kind of need a little space here. So it's 45. Okay, So now the goal is to get everything that's not an r on the other side. We're going to worry about that exponent of 2 last. Okay? But let's start with the fraction 1 over 2. What could I multiply both sides by to get rid of this fraction, 1 over 2? Yeah, 2. So if you said 2 over 1, that's the same thing. Let's do it times 2. Times 2. Half of 2 is gone. So now we've got 16 pi over 3. And it helps, you can think of it as you multiplied by 2 over 1. Okay. What's still on the right side? And r squared. So next thing we want to get rid of is pi over 4. How could we move the pi and the 4 to the other side? Yep. Times 4 over pi. And technically, you could have done all this in the last step. Okay, we broke it into 2 steps. Times 4 over pi. Times 4 over pi. What cancels on the right? 4's and the pi's? How about on the left? Pi's. So there's no pi left in the problem. 4 times 16, 64. Only thing in the bottom is a 3. Now, almost have our radius, but right now we have our radius squared. We just want radius. So what do you do in math when you want to undo squaring?
You square the other side.
Square root.
Oh yeah,
Yeah.
that's what yeah.
So we're going to take the square root of what's on the right. And the way you square root a fraction is you just square root the top and the bottom separate. That's how you square root a fraction. Okay, so square and square root, that's gone. So that's good. What's the square root of 64? So that's nice. But the problem is with the square root of 3. You can't take the square root of 3 because it's not a perfect square. And I might have mentioned this at the beginning yesterday. Is this an okay answer? Why? What's wrong with it? Right, you're not allowed to leave a square root in the bottom. So as far as the trig stuff and all, I mean, that's all done. Now we're just playing with this arithmetic to make it so it doesn't have a square root in the bottom. Anyone remember what I said you have to multiply by to fix having a square root in the bottom? Well, you got to multiply by the same thing here and here. It's going to. It's the square root of 3. Because whenever you multiply by the same thing in the top and the bottom, this fraction is really just what number? It's just a 1. You can always multiply something by 1 and it doesn't change it, but we've written 1 in a very special way. Square root of 3 over square root of 3. So what happens is 8 times the square root of 3. That's all you get in the top. And the square root of 3 times the square root of 3 is the square root of 9, which is how much? 3. So you can't get rid of the square root, but what you can do is put it in the top. So that was r. What's r stand for again?
Radius.
Radius. Radius is a measure of how long something is. So what should I have for a label on that? Just inches, right? Not inches squared. And again, that's the longest one because you got the square root thing at the end. And sometimes that doesn't happen. Like if the bottom was had a 4 in it, square root of 4 would have just been 2. Would have got a nice answer. But that's pretty much the worst case that can happen. Okay. Questions on that? All right, so last case. So the last case is when you have area, you have the radius, you have to find the angle. As long as they give you the radius, you're not going to have to worry about that square root stuff. All right, so start with our formula. What's my formula for the area? All right. Go letter by letter from left to right. Do we know A? Yeah, in this case, they made it very simple. They didn't even write it as a word problem. They just told you, this is this, this is this. So A is pi over 2. Do we know R? Yep. What is it? 3. And do we know theta? No. Now, we have a little bit of arithmetic to do on the right, but I would do it and leave it as a fraction. If you leave it as a fraction, it's a lot easier to do it. If you make it a decimal, it's going to get harder. So, what do you get when you square 3? 9. And now you're taking half of it. Let's just leave it as 9 halves. It is 4.5, but if you write it as 4.5, it's going to be harder to do it next step. 3 squared is 9, and then times a half is 9 over 2. Now, this is the same thing we've seen a few times. You've got a fraction, and you want to move both of the numbers to the other side. So what do you do on both sides? Yep, multiply by the reciprocal, which is how much here? What is it? I heard a couple things. 2 over 9. Yeah, the pi's on the other side. So all you got to multiply by is 2 over 9. 2 over 9. 9's are gone. 2's are gone. 2's are gone. So like 6 things just canceled out. What does that give me on the left? Pi over 9 equals, and what's on the right? Theta. So pi over 9 is my angle. It's in radians, so I don't need to put a label. And that's how you find the angle. Okay, questions on that? All right, so in the homework tonight, I think up to the last 3 or 4 questions, they're all pretty much like examples 1 through 7. The last maybe 3 questions or so are word problems. So one of them they're going to give you is about a clock, like the hands of a clock. And they may ask you something like, if the hand moved from 12 to 4, how far did it move? How far did the tip of the minute hand move? As the minute hand moves on a clock, what kind of shape does the tip make? Like if there was like a little pen on the end of it and it traced it on a piece of paper. If it went all the way around, it would be a circle. But how about if it just went from 12 to 4? It would make an arc. Just like that. So if you want to find the length of that arc, you need 2 things. You need the radius and you need the angle. Well, on a clock, the radius is really the what? What about the hand? The length, yeah. If you know the length of the hand, that's the radius. Okay? So maybe that's like 4 inches. This part is your angle. Now, the nice thing about a clock is everything is evenly spaced. So you can figure out what that angle is. It's 4 sections of a clock. 12. I consider 12 to 1. That's a section. 1 to 2, 2 to 3, 3 to 4. So all we have to do is really figure out how much each section is worth on a clock. And then we can figure out, we have 4 of them. Go from there. So you think they have a way to figure out what each section is worth on a clock? Yeah.
Divide 360 by 12.
Yeah. It's 360 degrees all the way around. There's 12 sections. So if you want to figure out your angle, 360 divided by 12 is 30. So each section is worth 30 degrees. 30, 60, 90 if it stopped at 3. So how many degrees is it from 12 to 4? 120. Right? So there's your angle. 120 degrees. And the length of the minute hand is 5 inches. You've got your angle, you've got your radius. You can find the length of the arc that the minute hand makes. Another one in the homework is about a pendulum swinging back and forth. As a pendulum swings back and forth, like if there was a pen on it and it was like on the board, what shape would it make? It's an arc. So as a pendulum swings, it makes an arc. The length of the pendulum is your what? It's your radius. If it went all the way around, it would make a full circle. So the length of the pendulum is your radius. And for this, they'd have to tell you the angle. They'd say the pendulum swings through an angle of 30 degrees. So if you knew that was 30 degrees, and you knew the pendulum was like 2 feet long, you could figure out how far back and forth it's going to swing. All right. So I think questions 91 to 94 have to do with these diagrams. Okay. All right. So the homework on page 99 is 71 to 87, odd, and then 91 to 94, all. If there is no class tomorrow, then we're going to skip 2.1 part 3 and have our test on Friday. If this is normal day, we'll do 2.1 part 3 and then test on Friday. If there's a delay, well, that means I'll see you and I'll figure it out then. So, either way though, we'll have our first test on Friday. My extra help day would normally be tomorrow, unless there's no school, then I will not be here. So, but I usually check my email, so you could email me, and if it's a math thing, I can try to explain it the best I can over email, but sometimes that's kind of hard.